Welcome to Part 8 of Competency 10. In this video, we will answer questions relating to calculus and antiderivatives. Okay, before we begin, please take note of the primary integrals of trig functions, okay, and how they're pretty basic and they work exactly opposite of your derivatives. Now, look at your k. This is a coefficient. And then let's look at our final answers. Okay? Really, what's happening is k is not becoming negative on the first one or the third one. That is actually the integral of the given. So k is the coefficient that we pull to the front, and then we work our integration, and then we put it back, or rather multiply it in. If you're familiar with integration and your derivatives, you'll be familiar with this concept. If you are not, do yourself a favor and look at the end of one of my videos. There is a suggested YouTube channel there, where that channel, you just put in what you're looking for, and it's fabulous. This person goes in depth, explains it well, and has many followers. So I highly recommend that if it's been a while or you just didn't take enough calculus, okay? All right, so let's move on and let's look at number 1 here. Okay. For this integral, we are looking for, it gives you the integral and then it says is equivalent to which function. Now we have a few of those to start, just to see if you're used to it. Do you know the basic rules? Is what we're saying. Okay. Well, we integrate term by term. If you look at the first term, 5 should be on its own. We don't integrate that. Okay. But then x becomes x squared over 2. So this is what's happening. It becomes 5, and that x becomes x squared over 2. Well, in this situation, obviously you could write that differently, which is what we generally do. Well, sometimes I just write it like this. It doesn't matter, okay? Well, now, if we go to our A and B options, they satisfy that first term. But C and D do not, okay? They jumped up, instead of adding on one whole number to that uh, exponent, they just slammed 2 on there all of a sudden. Well, that is an integration. Okay, so that won't work. And look at D. It's like they played the reciprocal game with the your coefficient. That we cannot do. So that's out. Now let's look at A and B. Well, for A and B, they forgot something on B, rather, they forgot something very important, the plus C. Okay. Well, why do we need the plus C? If you remember, when we integrated, or rather when we take a derivative, we have a constant, and whatever that constant is, it just simply becomes 0. Well, when you integrate, you're going backwards. Well, you have to put that constant back on. We don't know what the constant is. That's why we use a capital letter. In most textbooks, in most situations, we use C. I've seen a lot. It honestly doesn't matter what our capital letter is. It just represents a constant, okay? I've seen A used in certain textbooks. Okay, now let's look at number 2. Oh, A is our option there. Okay, so now we have a function to integrate, and they're asking is equivalent to which function? Same concept. Now, this number 9, we just put an x behind it. You just put the x back on that you took off when you when we took the first derivative. So 9x should be the first term. So A and B satisfy. Well, so does D. Yeah, so those three are okay. But let's look at C. That's not even the right term. They took the term and moved it to the negative. If you start positive, when you're using a constant, the constant cannot mysteriously become negative. Now, I do agree when we're integrating or finding derivatives between sine, cosine, yes, there is a negative that comes into play, but not when we're dealing with a constant. The 9 was positive, it must stay positive. So now we know that C is not going to be sufficient. Okay, now the next term. Yes, it has to remain negative, and all three do. But what is really going on here with this 7 over x? How we should really say it is like this: -7 and then times 1 over x. Well, as I told you, we will be integrating. I don't know, pretend like I can write correctly. We integrate the 1 over x, and the -7 hangs on its own. Now that I'm saying that, make sure the 7 is there in our options. D has a 7, B has a -7. It's completely missing in A. So I'm going to say A doesn't do it. It doesn't satisfy. Okay. And when we integrate 1 over x, we actually obtain, this should become -7 ln x. Okay, now that being said, go back to A. It looks like they transposed the x and the 7. So that's another reason why it's not acceptable. Okay, now B is Captain Obvious. It isn't going to work because, once again, missing the crucial plus C. Okay, and it also has a random X thrown in. They just decided, oh, we need an extra X. So that will not satisfy. And if you look at D, obviously it has all the things that are necessary term by term that we need. Okay, let's go to number 3. Number 3. Again, we have the same situation. We have a function to integrate, and it asks us which is the equivalent function. Okay, well, term by term again. The first term is 8 to the x power, the power of x. Okay, A and B should automatically get your I. That doesn't work. It's not the rules of integration at all. Now, it would have worked if we just had 8 on its own. Then we integrate, we get 8x. So obviously, the first terms in A and B, they're contrary to the rules of integration. So that isn't going to work. Okay, now let's look at C and D. Okay, one, if you remember how to integrate this, you end up with the 8x. Okay, 8 to the power of x, which both of the options do. And then the first option here with the 1 over ln 8, and then D has as a denominator ln 8. Well, those are the same thing. So essentially, you can say check mark on both those because they both satisfy. What we need to do is look at the second term for C and D. Now they have the capital C, so those are good. But let's look at how you integrate that second term. The negatives I agree with. Now remember, I said the K, the coefficient, which in this case is 3 over 4, they remain the same. They do not change, but they can be multiplied to a value later. Okay, so what should we have? We should see negative 3/4, and then the actual integration occurs with x to the fourth. Well, what do? Well, that means that we would have negative 3/4 times, okay, x to the fifth over 5, okay? All right, well, that can also be written naturally, of course. We would have 3/4 times 1/5 times the x to the fifth. Now that I've written that, you can see that D doesn't satisfy. They have their x to the fifth correct, but they completely forgot this 5. And what happened to the 4? It just mysteriously disappeared. So this means if I multiply 4 times 5, I will have a denominator of 20. And this means that the option C does satisfy what we're looking for. Okay. All right. Let's move on to number 4. Okay. Now, again, and we're doing the exact same thing with 1/2 times cosine x. Well, there's some things we need to remember. And the first thing is the same thing going on with this value of k, 1/2. It's out there on its own. And because we're dealing with cosine x, that is a trig function. That trig function, as it is, will have no numerical values involved when we integrate. So that means our denominator of 2 has to stay the same. Well, I say that because look at what B did. Okay, all of a sudden there's an extra 2 from somewhere. The 4 just shows up. Well, instead of 2, it's 2 times 2. Well, where do we get the other 2 from to multiply? That doesn't follow the rules of integration for that trig function. So B can't work. Now, I do agree with A because we know that when we integrate cosine x, we do get sine x. And if we put them together, that looks correct. Let's investigate what's wrong with C and D. Well, I see the half where it belongs, but doesn't 1 over x and 1 over cosine x mean something completely different? Well, those are secant and cosecant. Okay, well, that just doesn't relate with what we're doing. That's a whole other integration situation, whole other trig identities, simplifying. So they just kind of pulled that out and stuck it in. It doesn't make sense in this context. So naturally those won't work. So the only option that actually works and makes sense and follows the rules is option A. Okay? All right. Now let's go to number 5. I'm looking at it. Okay. We have the same situation again, and we have this 4 here. Okay. And if you remember, when we integrate cotangent and tangent, we should have an ln, a natural logarithm situation. Okay. First off, that 4 on that term is hanging on. We integrate the trig function and then we just put it back in front. Well, option B does not follow that pattern, and neither does B. That is not what we do with the 4. We do not stick it in with the angle measure. That just doesn't work. So B and D simply don't follow the rules of integration. Now, for the first term, the 4 works. But when we looked at the first of the video, and You can go back and take a screenshot of that if you like, or if you have your notes. Cotangent, it should integrate to become sine. And tangent and positive, it will be positive. So A is positive, but that is not sine. Now let's look at C. That first term follows integration rules. And then for tangent, that actually becomes negative. It should be negative cosine. Okay. And of course, that's a 1. So we don't worry about the exponent value, that k that we had. So C is the only option that follows the rules. If you look at A, it looks like they got these backwards. They've been mixed up or transposed. Okay. So A doesn't work either. All right. Now, for number 6, things have changed. Now we'll use our calculator. If you probably noticed we hadn't punched anything in yet, no buttons were pushed. Now we will. What is the value of this integral from 0 to 4? Okay, this will be very simple. I like getting these. They're in testing, I'll be honest, we don't get them a whole lot. Yeah, too simple, not rigorous enough, I suppose. Okay, so we need to push alpha window and go to number 4, and it shows up for us. We put in the 0, and then we arrow up, put in your 4, then arrow to the right, put in the function you have, which is x squared, and then we say plus 3. Now we have to arrow over and put in our x. Now push enter. Now we get a decimal. I see a decimal option, but I disagree with it. That decimal does not round to this decimal. That is a repeating decimal, and as we all know, that is absolutely 100% not the same thing. So how do we get what we need quickly? I mean, I know that you can see it, but what we need to do is we need to push math. The number we need is highlighted, so we push enter and enter again, and we get our answer, which is option B. Okay, all right, all right. If you've noticed, if you watched any of the videos with me, that happens a lot. That is one of the useful functions of the TI-84. You don't have to go and guess with these values. Okay, all right. So let's go to the next number. Let's go to number 7. For number 7, what is the value of this integral? Okay, so we do exactly the same thing we did for number 6. So we push alpha window, and number 4 is the option we want. Okay, now we need to enter this as we see it. You must enter the pi over 2. Okay, so use second caret up, okay, and then divide by 2. Now, you can, if you want, you could use the fraction mode. I'll show you how to do that. It works here too, okay, just in case you were thinking that you couldn't put in a fraction. So what do? We say alpha window, we go over, and we just need our number 1. Okay, and now you can just enter it as is, okay? So we have second pi, and then arrow down, pop in your 2. Now arrow up all the way and enter your 2 pi. So number 2 and second caret up, arrow over, and now we put in our actual function. Okay, and that is simply sine x. And I like to close that parentheses, okay? And then we need d of x, all right? And push enter, and it's -1. Okay, saves a ton of time. If I'm sure you've all done integration step by step, going through the motions, it can be so tedious with your eyeballs crossing sometimes. I love the TI-84 when it comes to this. It's so much easier. Okay, let's go to number 8. What is the area of the region bounded by the function f of x equals 5 over x? The line x equals 1 and the line x equals 6. Okay, well, we literally are going to graph this and put in that's actually an interval. They're saying this interval 1, 2, 6. Okay, we're literally going to use that in a way. If you've done it before, if you haven't, I'll show you. Okay, and we'll just get that. Okay, so let's put it in. And we can actually do it the same way, to be honest with you. So let's say alpha window number 4, and we have 1 caret up 6. Now, we can use our fraction option here. Alpha window, go over number 1, and then we have 5 arrow down. Our x, go over, and there's our x again. Let's push enter, and we simply round. Okay? All right. So that would be when we round. Ooh, all these numbers are very similar. But option B is what we need. Okay? All right. Now, this is the one that is going to be a twinge different. Okay? I kind of thought on number 8 that we could do that. And I thought, no, that's not what they're asking. Number 9 is. Okay? The diagram describes the function negative x squared plus 4. What is the area of the shaded region? So that's how you know what to do differently. It's the difference of saying what is the value, what is the area. Okay, that is our difference. Okay, all right. So what we need to do is go to our y equals. I already have it populated. Okay, so let's graph it. Oh, we need to zoom in a bit. Let's just do the number 6 standard and see if it pops. There we go. Okay, so what we do for this, it's actually simpler than what you thought. But we do need to look carefully at our image. Be very, very careful, and I'll tell you why. This is -5 is we're only looking at x values, okay? So that is -5. And this guy right here has the -2. Okay. Let me erase so you can actually, I'll circle the hole. At that point, we need -5. Okay. So we're going from the distance from this line over to here to this -2. And then we go from -2 to the 2. Okay. Here's the thing. You cannot successfully just enter these, all right? Okay? You have to do them, uh, you can do them separately. And let me see. There's actually 2 ways I think you can do this, all right? There's more than one way. Okay, so what we're going to do is use the image, okay, by actually just letting the calculator draw in our shaded area. However, we're going to need to be careful, and I'll show you why. So let's use second trace, okay? What we need is number 7. So push 7, and it says lower limit. Well, our lower limit is the first thing. We're going to read it going this way, okay? Our lower limit is -5, okay? So literally just push in the -5. See how it says -5. Push enter, okay? Now it says upper limit. Well, we go to the next one that I've circled, which is the -2. So push -2, push enter. And that's our shaded region. But we have a problem. When you read it, it says that that is -27. And the reason it says that is because it is below this is our, obviously, because this is the origin here, this is our x-axis. That shaded region is in the negative region. What we need to do is take into account, this is a calculator thing, simply just say absolute value of 7, okay? And then we'll add it to the next region, okay? So we repeat our process. This is what you do. We need to say second, go back and do it all over again, and then push number 7, and our lower bound is the -2. So push -2 and enter, okay? Upper bound, well, that is 2. So push the 2 and enter, and it populates it. So your calculator looks like my drawing, okay? Now, only thing is you can't see the bottom part, but it doesn't matter. Now, this time, because it's above the x-axis, they give us a positive value, and that is 10.6666. Well, it's repeating, okay? And the calculator rounds it to 7, but again, that's a calculator thing, and we know that that is simply repeating. Well, here's what we need to do. There's a couple ways to do it. One, we look at our options and we say, okay, A can't be it because we're taking the absolute value of 27. We're talking about area. And regardless if the area is in the positive region or the negative region, area is area. And we're going to have to add those together. So we know 27 won't work. And 37, okay, that is not accurate because we have this whole decimal here, this repeating 6, so that's not going to work. And now we look over here at our other options. Well, we have 2/3, and yes, 2/3 is equal to 6 repeating, okay, 0.6 repeating. Okay, but they forgot to add them together. So honestly, just by looking at this problem and those options, we see that it's option D. Let's go ahead and put that into the calculator and we'll see what we need, okay? So, but at least we got a nice looking picture and it gave us the regions that we needed, okay? All right, so let's get second mode to get out. And absolute value, I always just push second and I go to 0 where it says catalog. And I do that because it's the first one up, okay? See where it says ABS, okay? Push enter. And in that, I just type in my -27, arrow over, and say plus 10.66666. And I put in several just for safety. Push enter. Okay. All right. So then, obviously, to get that fraction, math, and enter again. Oh boy, oh boy, oh boy. We're going to have to change it again. Okay, we know what the answer is, but this is a good way just to see an exact answer. Well, we know that the denominator has to be 3. That's a dead giveaway. Okay, let's see. Second window. Uh-oh, sorry. That should be alpha window. Back out of that. Alpha window. Okay, then I arrow over and I want number 2. Oh, that's not gonna work either. I always do this. Okay, alpha window, arrow over. Oh, it's number 3 where it changes back and forth. That's the one we want. Now, let me see if it says answer. That's another thing. If it doesn't say answer right there, then you got to go back and start over, which I've had to do. But there you go. It helps when you push the right buttons, correct? Yes. Okay, that was the last question in this video. And you know what? I really appreciate it, guys, that you're watching, even though I may say extra things and maybe give you more information than what you really want. But the reactions have been fabulous. I've had sharing and liking, the viewing is going up, and people are subscribing. That we most appreciate. We need the subscriptions in order to keep the channel going. And once again, happy testing.